I'm Dr. B. Srividya, Professor, Department of Chemistry. The topic what I'm going to present is chemical sensors. Chemical sensors are the devices that detect and measure chemical substances in the environment or a given medium by converting the chemical information into a measurable signal. These sensors play a crucial role in applications like environmental monitoring, industrial safety, medical diagnostics, and food quality assessment. The characteristics of chemical sensors. The performance of the sensors is defined by the several key characteristics which include selectivity, which is nothing but the ability to differentiate between the target chemical substance and other interfering substances. It can be achieved through specialized sensor designs such as molecular recognition elements or selective membranes. Sensitivity. The sensor's capability to detect low concentrations of the target chemical. It is defined as a change in the output signal per unit change in the analyte concentration. Next is the response time. It is the time taken by the sensor to reach a stable output after exposure to the analyte, and it is critical in real-time monitoring applications. The next characteristic is stability. It is nothing but the ability of the sensor to maintain consistent performance over time under operating conditions, and long-term stability is influenced by material degradation and environmental factors. Next characteristic is the range, the concentration range within which the sensor provides accurate and reliable measurements. It is often optimized based on specific application needs. Linearity, the degree to which the sensor's output signal is directly proportional to the analyte concentration within its operating range. Reproducibility, the sensor's capability to produce consistent results under identical conditions over multiple measurements. Next is the robustness and durability, sensors' resistance to physical, chemical, or environmental conditions such as temperature, humidity, and mechanical shock. Size and power consumption. Sensors are compact, low power designs are preferred for portable or wearable applications. Cost effectiveness. Sensors need to balance performance with affordability, especially for large scale development. What are the elements of chemical sensors? The typical chemical sensors comprises of the following key components. Basic is receptor, also recognition element. These are responsible for the selective interaction with the target analyte. Examples includes enzymes, antibodies, polymers, molecularly imprinted materials, and nanomaterials. Next is the transducer, which converts the chemical interaction into a measurable signal. Example, electrical, optical, thermal, or mechanical. Types of transducers include electrochemical, which measures the changes in current, voltage, or impedance; optical, which detects the changes in light absorption, emission, or refraction; mass sensitive, monitors changes in mass or acoustic waves. Then thermal, which measures the changes in temperature or heat due to chemical reactions. The next element is a signal processor, which amplifies, filters, converts the transduced signal into a format which is suitable for display for further analysis, which includes microcontrollers, analog to digital converters, and algorithms for data interpretations. The next element is the output interface, which displays the processed signal into a readable format, such as a digital readout, graphical display, or an alarm. And the following is the block diagram of the chemical sensor. Then what is the principle behind the chemical sensor? First one is the analyte detection. The target chemical substance called as analyte interacts with the receptor element, which can be enzymes, polymers, or nanomaterials. This interaction can involve adsorption, chemical bonding, or a biochemical reaction. The next is the signal conversion, transduction. The transducer converts the chemical interaction into a measurable physical signal, which can be electrical, optical, thermal, or mechanical. Next is the signal processing. The raw signal is processed to remove the noise, amplified, and converted into a usable format. It can be voltage or digital signal. Next one is the output display. The processed signal is displayed as a readable format such as numerical data, graphs, or triggering of alarms. Chemical sensors advantages. First one is high sensitivity, which can detect trace amounts of analytes, making them suitable for low concentration applications. Then high selectivity. It is designed for specifically interact with the target substances, reducing false positives. Real-time monitoring, capable of providing immediate feedback, critical for safety and diagnostic applications. It is compact, portable, which is small sized, lightweight designs allowed for use in field applications, wide application range. It is used in diverse fields such as medical diagnostics, environmental monitoring, and industrial safety. Automation friendly, easily integrated with automated systems and IoT platforms for remote monitoring. Disadvantages: interference, presence of similar compounds or contaminants can affect accuracy and selectivity, limited lifespan, degradation of the sensing materials over time leads to reduced performance and stability, environmental sensitivity, factors such as temperature, humidity, and pH can influence sensor behavior. Calibration requirements. Frequent calibration is necessary to maintain accuracy. Cost. High performance sensors with specialized materials or complex designs can be expensive. Maintenance. Regular maintenance is needed to ensure long-term functionality, especially in harsh environments. Applications of sensors. Medical diagnostics used as glucose sensors, breath analyzers, and biosensors for disease detection. In environmental monitoring, it can be used as gas sensors for air quality, water quality sensors for pollutants, industrial safety, sensors for hazardous gases process monitoring, food quality, sensors are used in detecting contaminants, freshness, and spoilage indicators. Thank you.